Welcome to another Los Angeles Unified STEAM Bytes. I'm Jerry Song, STEAM Coordinator for the Division of Instruction, and I'm joined by Jaspreet Sanda, the other STEAM Coordinator for the Division of Instruction. Jaspreet will introduce our speaker for today.
Thank you, Jerry. Today's guest speaker is breaking the traditional stereotypes of who were once believed to be working as rocket scientists. Cassie Roby graduated from Florida State University in May 2020 with a bachelor's and a master's degree in mechanical engineering. As she works part-time for Northrop Grumman in Redondo Beach as a space thermal engineer. As a space thermal engineer, Cassie maintains thermal control on various space systems. In this role, she creates detailed designs such as 3D modeling and coding, as well as integration and tests. In the other half of her time, Cassie has recently started working for NASA on the James Webb Space Telescope. She works at the Mission Operations Centers in Baltimore, Maryland, where she is part of the thermal control system for the James Webb Telescope. Outside of work, Cassie has a STEM outreach program called Space Girls. The goal is to encourage girls in Los Angeles and all around California to become more aware and participate in STEM fields. In April of 2022, Cassie was crowned as Miss Los Angeles County, and in June, she'll be competing for Miss California. Please welcome Cassie Roby.
Hello, everybody. My name is Cassie Roby. I am so excited to be here today. I am the current Miss Los Angeles County 2022, and I have my own program called Space Girls, where I advise, communicate, and educate girls all across the state and across America to join STEM and to get into STEM. We're going to talk a little bit about my background, how I got into STEM, what my childhood was like, going into college, what decisions I made, how I decided to pick my major, and then later on pick my career. And then we're going to talk about my current career, which is at Northrop Grumman as a thermal engineer, doing design and systems work, and then as well as NASA as a thermal flight operations engineer. So growing up, I actually am originally from Louisville, Kentucky. And so that was always interesting growing up there with the horses. I always grew up kind of near a farm. My aunt had a big farm we'd always go out to. I have one older sister, and she has always been a big inspiration for me. She is a role model to me. She always helps me out, critiques my resumes, gives me advice. And so she's always been a big influence in my life. And then when I was in the fourth grade, we moved to a place called Destin, Florida. And that's a really big tourist city. It's known for its like world-class white sandy beaches. And when I was there, I went to middle school. I went to Destin Middle School, where I was a baton twirler. I actually started the baton twirling team there with help from the band director. And then I was also on the volleyball team. And so I really loved athletics, and I was always involved in that. Moving on into high school, I attended Niceville High School, which is a really small city just outside of Destin. And there I, kind of found my passion for math and science. I was on the majorette team there. So I was in the band from middle school to high school, and then I even went on to college in the band. And so some of the classes that I ended up taking in high school really kind of paved the way for my college experience. And so some of the electives I chose, a lot of them were AP classes, which I think is really beneficial. And so if you're a high school student or a middle school student and you're thinking about what should I take to kind of get some college and high school credits, consider what your school has to offer. Some of the classes I took were AP Language, AP Literature, AP Statistics, Calculus 1, US History, US Government, and World History were all AP classes, as well as physics. And then I also, again, was in the marching band. I did some web design classes. And then I also did study hall and was a teacher's assistant as well. And so these are some of the pictures. I have a picture from one of our homecomings one year, a picture when, I got my first car and I learned how to drive, and then pictures at my graduation, which actually was a funny story because my graduation was hosted outside, and the first night it was canceled because there was a big rainstorm. And so they sent everybody home and told us to come back the next day to try again. And then the next day it rained, I think even harder. And so they continued on with the show. And so my high school graduation, all I remember was sitting and just getting completely rained on the entire time. So going on, when I was in high school and I was thinking about where I wanted to go to college, I considered a bunch of different options like Ole Miss, University of Kentucky, University of Louisville, and then Florida State University. And some of my top 3 priorities when I was looking into different colleges included the tuition, how much was it going to cost? There's in-state tuition versus out-of-state tuition, what scholarships were available. The second was baton twirling. I had been baton twirling since elementary school. And so it was a big part of my life and something that I knew I wanted to do in college. And then finally, the education. At the time, I still didn't really know what I wanted to major in. And so I wasn't really sure about, what college should I be looking at. And so this is going to be different for every person. And so for those looking at going to colleges and you're considering your options, what are your top 3 things that you're looking at? And they're going to be different than mine. They should be. If you know for sure that you want to be a mechanical engineer, you want to be an entrepreneur, look at the schools that have, good programs for that, good paths for you to build a career, build your own business. And so everybody's path's going to look a little bit different, but these were, my top 3 choices and what led me to eventually pick my school of Florida State University. So my freshman year, I attended Florida State University. Some of the things that I did to help me get involved and get acclimated to the college life was I was a majorette again in the marching band. I was also on the dorm hall council. And so this was my residency. My freshman year was in a dorm, and they had a hall council that helped put on different events for students. So it was a really good engagement event, allowed me to meet a lot of new people. And then I also, some of the stuff I did is I took the basic English classes, computer competency, ethics, as well as calculus too. So some of the freshman level courses, and then as well as calculus 2, because I was able to pass the AP Calc test. And so that allowed me to, save a semester of work and go straight into Calc 2. And then I did do summer classes that year. I did physics 1, and I also did a programming lab. But like I said, my freshman year, I didn't know what I wanted to major in. And so my freshman year, I think I really found that. I really, established that passion for math and science. I came in my freshman year as a statistics major, and halfway through is when I decided to change to engineering. And in order to stay on pace with the rest of the freshman engineering students is why I did those summer classes. Moving on to my sophomore year, again, I was a majorette in the band. I was also a teacher's assistant for thermodynamics. And so that was kind of a turning point for me because I really learned more about thermodynamics. I learned about thermal engineering, and that eventually led me to my career. Some of my major coursework included Intro to Engineering. I took statics. I also took physics 2, chemistry, as well as machine shop. I joined different organizations such as Kappa Gamma. I also joined the American Society of Mechanical Engineers, which we call ASME. I also was a part of the Society of Women Engineers, which is SWE. And then finally, I was able to obtain my first summer internship, and that was with BNSF Railway. That was in Fort Worth, Texas, where I worked on different trains and managing the dynamic forces between the cars and the free slack that goes between them. And so they don't break and basically come apart while they're transporting items. Moving on to my junior year. So this year I was feature twirler in the marching band. And so feature twirler is a little bit different because I had more freedom. I didn't have to practice as much. And so I was able to put more work towards, my major or to some other activities I was involved in. Again, I was a teacher's assistant for thermodynamics. My major coursework included material science, thermal fluids, and dynamics. And so this year I even got to dive deeper into what thermal fluids really was. Again, I was a part of Kappa Kappa Gamma, ASME, and SWE, and I obtained a summer internship with Northrop Grumman. This was in Melbourne, Florida, where I worked on an aerospace program doing environmental qualification. And environmental qualification is basically making sure that everything on the aircraft is able to withstand its environment. And so you think of military aircrafts, because Northrop Grumman is a military contractor, they have to go into a bunch of different environments. You never really know where they're going to be required to be. So it could be in a very dry desert area where there's sand pelting the sides. It could be in a very humid, hot, wet environment, or it could be very cold, icy. And so you have to make sure that your equipment and that your aircraft is able to survive and perform as expected in all those different environments. Moving on to my senior year, again, I was feature twirler. I was a teacher's assistant. This time I was a teacher's assistant for the engineering design class. And I was a research assistant. I started becoming a research assistant at the National High Magnetic Field Laboratory. This was in cryogenics. And so cryogenics is like a thermal fluid type study, but it's everything at really cold temperatures. And so that's what the root word cryo means, is extremely cold. And so these are your elements that you normally think of in its gas state, like oxygen and nitrogen and things like that, or what I'm working in a liquid state. And so they have to be at very cold temperatures. I also was able to pick some electives. And so this is when it got more fun in the engineering world, because I got to actually pick my classes. And so I chose thermal design, materials 2 or some of my courses I picked. I also picked entrepreneurship, and then my senior design project is something I also had to do that was required. This year, I was still in Kappa Kappa Gamma and still in SWE, but I moved up to be the ASME Public Relations Chair, where I helped recruit new members to ASME, and so they could have a social network to help get them through engineering. And having that social network, being involved, is really crucial to any school experience you may have. And then finally, I got another summer internship with Northrop Grumman. And you're probably wondering, why did you do another internship when you graduated? And I'll get to that in a second. So I ended up at Northrop Grumman again. This time I was in Manhattan Beach, California, where I did product engineering. And so this was mainly a lot of CAD work. I had to work directly with the different electrical engineers for electronics and payloads, and I would basically CAD their electronic boxes for them that go inside the spacecraft. And so this was a space program that I was on. So I did do a victory lap, is what we call it, but this was also my graduate year. And so I ended up doing what is called a 4+1 program, which basically means that in 5 years, I was able to graduate with a bachelor's and a master's in mechanical engineering. And this is really special to me and really fit my needs, because it allowed me to twirl for another year in the band, and it allowed me to get my master's at an accelerated rate. So this is just one option if you're considering getting a master's. There are also other options. Many students will finish their bachelor's, go into the workforce, and then in a couple years down the road, a lot of companies will help pay for your master's if you're interested in going back into school. So this year, again, I was a teacher's assistant, this time for the senior design projects. And again, I was a research assistant at the cryogenics lab. My graduate electives included power generation, aerodynamics, and energy sustainability. I was in Kappa Kappa Gamma and SWE. And then this was when I started getting into pageants because I was done being a competitive baton twirler. And so I decided, why not give pageants a try? And so I joined the Miss America organization, which I'll talk about a little bit later. And I was crowned Miss Jacksonville, and then later went on to compete for Miss Florida. So then after I graduated, I decided to move across the country in the middle of the pandemic. And so this was about June 2020, where I picked up and moved from Florida all the way out to California. So what am I doing now? Right now, I'm working for Northrop Grumman as a thermal design engineer. This is in Redondo Beach, California. And I am a space thermal design engineer. My program is in space. And so mainly what I work on are different types of satellites. And so this could be your GPS satellites, your communication satellites. So every time you pick up your phone and you type in an address, or you text somebody, or you give somebody a call, you're using a satellite. And so although we don't see it every day, it kind of seems out of touch with our day-to-day lives. We are using them all the time. So what is thermal design engineering? So basically my job as a thermal design engineer is to make sure everything on the spacecraft is not too hot, not too cold, but just right. And this is really important because of the extreme temperature swings in space. And just like your computers or your phones or your TVs, even your refrigerator in your kitchen, all has thermal control built into it to make sure that it's able to operate properly. If your fridge gets too cold and you open it up and everything is frozen, you wouldn't be very happy, right? You wouldn't, be able to eat your favorite snacks or whatever. And so making sure that everything is thermally controlled is really important. So what are some of the responsibilities of space thermal engineers? So some of the responsibilities include having an awareness of the system. And so like I said a little bit earlier when I was talking about my role as a thermal engineer, it's a thermal design, but it's also a thermal systems engineering role. And so when you have to have an awareness of the system level, you have to consider a couple different things, and you have to consider how the entire vehicle is going to work together. You can't just consider one box. Like when I was an intern and I was doing the CAD design for one box, that was my only focus. I didn't think about how that box was going to interact with maybe another electronic box that gets put next to it, or how that electronic box is going to dissipate heat to the panel, and how that panel is going to be able to spread heat among the bus, which the bus of a spacecraft is that central part of the spacecraft where all the electronics are held. And so being able to do that at a system level is really important for thermal engineers. And so we know how my computer that is sitting on a table is going to heat up the table, and how if I put another computer next to it that's working really hard and giving off a lot of heat, how that's going to affect both the table as well as the computer next to it. Next, we have to provide thermal control. And so we do this in a couple of different ways. And we do this through both passive and active technologies. And so a passive technology is one that doesn't really need any more power. It doesn't need service, or it doesn't need communication. And then active thermal control is something that is actively working with our onboard computer, actively working with the ground command, and we are sending it up commands, and it's able to react and respond. Whereas passive, we don't really have any control once it leaves Earth. We have to trust that it's going to operate the way we designed it to. Next, we have to verify performance. We have to do this in two different ways. One is through different analysis. And so this is really important because making sure that we have good models and making sure that we have correlated models that are actually going to behave the way the spacecraft does is important in making sure that we're able to actually predict what temperatures we're going to get. And so we do that through our different models, and then to correlate our models, we do different types of tests. As a thermal engineer, we do two main tests. One is called a thermal cycle test, and this will make the vehicle go kind of like the life cycle or an orbit that it's going to experience in space. And so we'll go from the main hot temperatures all the way up to when it's in full view of the sun, and then it'll go cycle down to the extreme cold temperatures when it's blocked to the sun by the earth and it's completely shaded and going to get very cold. And then we'll cycle it back up to that extreme hot, kind of like how it's going to behave in space. And then the second kind of test is called a thermal balance test. And then instead of cycling this, we actually hold at that extreme hot temperature and we let everything stabilize. So we let everything get to its steady state temperature. And so we know exactly how hot it will get on orbit. And then we do the same for the cold side. So we go to the extreme cold side and let everything again go to steady state where it's at its equilibrium temperature. And then we verify what temperature it's going to be in that configuration. And so in order to do these tests, we as thermal engineers have to help plan and support this testing. So we'll be the ones that are writing the test procedures as well as the ones who are sitting in the lab at the test. And so my day-to-day job isn't necessarily always at a computer doing analysis. My day-to-day job varies from going from making PowerPoints about different thermistors and thermostats, to doing detailed analysis and design, to being on the floor looking at hardware and making sure it's going to be thermally okay, to even supporting a test and making sure everything's running properly in a lab. And then finally, the really cool thing about being an engineer is that we actually do to see the entire design cycle, including the launch. So when we launch these up into space, we get to be a part of those activities. So let's talk a little bit more about the spacecraft environment. And so here we have our satellite, and we also have the Earth and the sun. And the Earth and the sun are going to be the main two drivers that affect this satellite in its orbit. And so we have heat from the sun, and we also have heat from the Earth that are going to affect it. And so something to point out is that as this satellite goes around its orbit, that it's going to be in full view of the sun at times, it's also going to be completely shaded from the Earth. And so while we have to consider different power modes of the vehicle, we also have to consider what is its orbit and how is that going to look. So moving on to some thermal engineering tools, some of the softwares we use. So the cool thing about being a thermal engineer is that I get to do both CAD and code. And so the first thing we do is we create a 3D model of the spacecraft in space. And so this is your 3D modeling, your CATIA, your AutoCAD, your PTC Creo, all those different types of programs are like that. We specifically at Northrop Grumman for thermal engineering use TSS on my program because it's an older program. We also use AutoCAD Thermal Desktop, which is kind of replacing TSS and is leading the way right now in the thermal engineering industry, especially for aerospace. And what we're able to do with these 3D models is we're able to collect heat transfer based on the environment. So we looked back at that slide before, we had an environmental condition based off the sun and based off the Earth. And so how are those heats getting off, transferring onto the vehicle is really important to know and understand. And that's what this 3D model does for us, is it gives us those different rates and how the vehicle is going to respond when it's in different stages of its orbit. What I really liked about thermal engineering and our 3D models is that they don't have to be as detailed as what I was doing when I was working product engineering in my internship, because as thermal engineers, we're not completely concerned with the different types of brackets or the different types of screws or different types of threads that we may use, the nuts, the bolts, the washers. A lot of that we don't really consider because we're only considering the exterior surface of the vehicle, and the exterior surface is going to be covered in multi-layer insulation. And so we can make sure that everything is safe from the extreme temperatures of space. And so for me, that was kind of a good compromise. And so I could still do 3D modeling, but I didn't have to get into all the details because I was going to be covering it up with MLI. So these are some of those examples of those 3D models. And so we have both shown here. We have something at the system level. And so this will be the entire vehicle. And so on the outside, you have your solar panels, which are those orangey colors, and that will be warmer. And then closer to the core, you have the blue image, and that's more the interior of the space. And then on the other side of the screen, you'll have what we consider more of a component level thermal engineering model. And this is because while we also have to look at the system level, we also have to look at the component level and break things down into smaller elements and make sure they're going to work individually as well as work together. So like I said, we also do a coding program. And so we code the thermal conduction between the surfaces. And so before, the model was mainly based off radiation. Now this code is for conduction. And so we use basic thermal equations for conduction. This is Ka/L. And we do this using a program called Cinda. And so we've considered our conduction, we've considered our radiation, but what about convection? And so in space is a vacuum, which means that there's no air. And so as a thermal engineer, I don't have to consider convection because it doesn't exist in space, right? There's no air, there's no working or moving fluid to be able to have that convection of heat transfer. And so I combine my conduction and my radiation models together, and that's how I output temperatures and make temperature predictions for the vehicle. So going on to some thermal engineering tools that I have. This includes multi-layer insulation, which I talked about earlier. This can be silver or gold or black. It can be a variety of different colors based off what you need it to do. There's also temperature reading devices. This is thermistors or thermostats. We also have heaters and heat pipes. And so heat pipes are special because they're able to actually transport heat. And they do this inside with a working fluid. And so that is convection because there's able to have a working fluid inside these heat pipes that are able to move heat away from a certain source. And then we also have different types of materials as well as different types of tape. Like aluminum foil tape is really good at spreading the heat, as well as copper tape was we use to help spread the heat. So moving on to my other job, this is for the James Webb Space Telescope, which recently launched in December 2021 on the 25th. And I do thermal flight operations, and this is conjunction with NASA as well as the European Space Agency. So the James Webb Space Telescope is actually 1 million miles away from Earth. It is at an L2 point, which is called Lagrange point 2. And there's actually 5 different Lagrange points. And these are special because they help balance the gravitational pull between the Earth and the sun. And so the James Webb Space Telescope doesn't need much additional support in order to stay in its orbit. It doesn't need very frequent thruster support in order to help stay in its position. And this is also beneficial because, like we said earlier, the 2 main sources of heat are the Earth and the sun. And so in a traditional orbit, the satellite or telescope will be at a point where it's between both the Earth and the sun. Whereas the James Webb Space Telescope, because it's 1 million miles away from Earth, it's able to block that heat from both the Earth and the sun at all times. But the James Webb Space Telescope has really sensitive science instruments that work in the infrared wavelength. And the importance of that to know is because they have to stay really cold in order to operate to get our amazing pictures that we're going to be able to get and that we're starting to get currently. And so even 1,000,000 miles away from the Earth isn't enough to keep these as cold as they need to. And if we go back, I talked about working in a cryogenics lab, and that's the temperature levels that these science instruments are required to be at, or at these really extremely cold temperatures. And so what we did is we designed a 5-layer tennis court-sized sun shield. And this helps block the heat and light from the sun, the Earth, and the moon. And so this allows us to have 2 different sides of the James Webb Space Telescope. We have our hot side, which gets up to 185 degrees Fahrenheit. And this includes our solar panel, our communications antenna, our onboard computer, as well as the steering, which allows us to stay in orbit. And so all of these components are really critical. Our solar panel helps give us power. The communications antenna gives us telemetry down here on Earth, which is different types of data. Our computer helps process things, and then our steering helps us stay in orbit. And then the cold side, which is negative 388 degrees Fahrenheit, so very, very, very cold, has our science instruments like our detectors and our filters, as well as our mirrors. And our mirrors are the ones that really help capture all the different light and take our pictures for different science instruments. And so how does a sun shield work? Well, these 5 layers work because each layer is able to block heat. And then the heat that does get through then gets redirected out the sides. And it's also helpful that we are in a vacuum because that provides more insulation. And so this is a picture of it at Northrop Grumman. This was built at Northrop Grumman in Redondo Beach. And so right here, very local. And this is a picture of it deployed in one of our high bays. The only thing that's not deployed is the 2 side mirrors. And so you can kind of see on the side that those will fold out into the full primary mirror. So like I said, the James Webb launched from French Guiana on December 25th at 7:20 a.m. Eastern time. And it was launched in a ESA Ariane 5 rocket. ESA is the European Space Agency. And in order to fit Webb into the rocket, it had to be carefully folded. And so you can see here, so the left image is it completely stowed again at our high bay at Northrop Grumman. And then on the right is kind of like an animation of what it looks like when it's in the rocket before it's going to separate and then go off into space. And so we had a series of intricate deployments that allowed it to completely unfold into space. So where is James Webb now? It's currently fully deployed at its L2 home. Currently, the James Webb flight and science operations teams are working on cool down and instrument turn on testing and calibration. The mirrors are also undergoing alignment and calibration. And so what I do as a thermal engineer is, about once a month for about a week, I go to Baltimore, Maryland, where the Space Telescope Science Institute is located. And that is where the flight operations team is working and where the deployment operations teams were working for the James Webb Space Telescope. I monitor all the telemetry that we have, all the different temperature sensors. So those were our thermistors that we talked about earlier that are able to communicate with the onboard computer and then send us down different temperature rates. And so we know if everything is cooling and heating properly. We also have connection to our different heaters to make sure everything is heating up when it needs to heat up and it's not dropping below a cold acceptance value. And so this picture is one of the pictures that we were able to take from the launch vehicle right after James Webb separated from the rocket and went on into space. And so it's a really cool image because it actually shows James Webb in space. And so right now we're currently continuing to align the mirrors. That takes about 6 months. And so we're about halfway through that process. We're also working instrument turn on. The heaters are starting to turn off and the instruments are starting to cool down to their operational modes. And then we're going to be able to align those and calibrate those before we hand it off full time to NASA to do their science work. So a little bit more about myself really quick is I am Miss Los Angeles County. I am the founder of Space Girls. I also work with the Girl Scouts STEM Patrol. I'm a Real Talk ambassador. And then at Northrop Grumman, I'm a part of NGWIN, which is an employee resource group as the communications chair. The Miss America organization is what I'm a part of as Miss Los Angeles County and is the largest scholarship provider for women in the United States. So if that's something that you may be interested in, I 100% recommend that you give it a shot. The areas of competition include a 10-minute interview with the judges, talent, evening gown, onstage question. The teens will compete in a short fitness section, and then the Miss will compete in a short social impact initiative statement on stage. But the big driver for me, at least, was the scholarship money. And to date, I've won over $4,000 of scholarship money. And the current Miss America has won over $100,000 in scholarship money to help continue her education. So some of the local competitions in this area include Miss Los Angeles, Miss Culver City, Miss University Heights, Miss San Bernardino, and then Miss San Fernando Valley. So if you're interested, you can always reach out to me or any of the other young women that compete in this organization. And that is all I have. Thank you guys so much. If you scan the QR code, that goes to my website where you can see some resources I have. I also have a mentorship program, and it was so great talking to everybody. I hope you learned something, and thank you for having me.
Thank you, Cassie. Wow, that's a lot. I mean, you're really active, in high school and in college, which is hard for a lot of kids, to be a part of, a sports team and do what you can. So thinking about everything that you've done in high school and in college and being so active, in groups and in sports, and even being part of a sorority, what advice do you have for our students, to succeed and to become a thermal engineer? Because you're almost a rocket scientist, so what advice do you have for our kids?
Yeah, my biggest piece of advice would be to not be afraid to reach out to people, not be afraid to ask questions, and to really dive into anything that you're curious about. I always felt like my problem was not that I was afraid to ask questions, but I didn't want to bother anybody. I was like, oh, they're an adult, they're too busy to answer my questions. And what I found growing up is that that's not true, that people want to help. People want to give you answers to your questions. They want to be there to support you. And so working on gaining the confidence to ask those questions, and then gaining confidence in myself and rewarding myself for when I did get a good grade on a test, or when it was a really busy day and I made it through and I accomplished everything that was on my priority list. And so, asking questions, stepping outside of that comfort zone to ask questions, as well as rewarding themselves for even some of the little things that are hard to do.
And then what advice do you have for our parents and our teachers? Because adult support's so important, but a lot of our teachers and parents don't know how to support their kids. So what advice do you have for them?
Absolutely. So it's kind of a little bit of the same advice I give to the kids. I think that we always tell our kids, don't be afraid to ask questions, right? But then we don't ever tell our parents or our teachers or our adults that, because there's kind of like the stigma that once you get to a certain age, once you're an adult, you're supposed to have everything figured out and everything just clicks. And that's not necessarily true. We're all constantly learning and growing. And so don't be afraid to ask questions. Don't be afraid if you're a parent who has a child that's interested in STEM and you don't know anything about STEM, to ask their teacher, to go on Google and find local events that are available, to use your resources that you have. If you have a friend that's in engineering, you have a friend that's in mathematics, ask them. Just say, hey, my child's really interested in STEM. What should I do? Where should I go? And then the same for teachers. Reach out to different community groups, reach out to different companies. I know a lot of people use LinkedIn to connect with people. I know people that've been able to get internships off LinkedIn and be able to get resources. And so just don't be afraid to go out into your community and see what's out there. I know the Columbia Memorial Space Center even has a Girls in STEM Club. I know the Los Angeles County Office of Education does an Engaging Girls in STEM event every year. And so there are a lot of resources out there. Just don't be afraid to ask questions and look for them.
Well, thank you. And that's great advice, Cassie. That's great. Thank you so much for sharing your story. Thank you for teaching us what, thermal space engineering is. Something new to me, and I think it's also new to Jerry. But, it means a lot for you to share your story and just showing our girls that, they can do whatever they put their mind to. So thank you so much.
Thank you so much for having me anytime.